Okay, so let's turn over to the lab itself. I'm going to spend a brief amount of time talking about how the lab will be conducted and a little bit more in terms of policies of grading and things like that. There will be a follow-up video that will go into great detail about this idea of experimental design and how we're going to implement it in the lab. But let me just give you a few general overviews and some procedures so that you have some idea of what to expect. So each week we'll be doing a lab, and what that means is you will design a measurement. But you're not going to do this in a vacuum. So we have a website that will explain various things, and one of which will be posted what we call a cookbook lab, which you could follow the procedures in the cookbook lab and end up by measuring something. But it doesn't give you a chance to be creative or do anything interesting. Some of them are pretty dull, actually, but they can be spruced up if you figure out ways to vary it and ask some physics questions that you can then measure. So there will be a cookbook lab that you can read and go through and try to use that as a guide for the types of measurement that you can make. But then we'll ask you to go beyond that and design something more interesting. But these are there, and you can look at them, and there is a lot of other information on the website that you can read to sort of understand and guide you through what we'll be doing each week. So what we are doing here is more properly called an inquiry-based lab. So you are asking a question, and you're going to answer the question. And so this really gets at the core of the scientific method. How do you do a measurement? How do you understand the different components of the measurement? How do you construct something out of what you can measure to get at maybe a fundamental physical constant, for example? And then how do you evaluate the uncertainties in that process? You need to put an error bar on a measurement because you can't claim that you're measuring something with infinite precision. Everything has uncertainties due to equipment or procedures or whatever. And we want to give you some experience in estimating those kinds of things. So this slide here just gives a comparison between a sort of cookbook and inquiry-oriented labs. But the main points of the inquiry-based labs is that you are in charge. It's your creative process, and you are executing the scientific method in a way that scientists do. So this is what we're trying to get at with this lab. So this is kind of a cartoon to give you just kind of an idea. So we assume that if you've never done this before, you're starting in the lower left corner, where you read a cookbook lab at the very beginning, and then if the more you deviate from this, the more you learn about how to do science in a scientifically rigorous way. And so there are all kinds of things you can do to stretch beyond the cookbook lab. You can change what you're measuring. You can change how it's measured. You can decide that you're going to explore a different physical relationship of the same physical quantities. So there's a lot of things that you can try. And you can vary the different physical quantities to show that those relationships are valid, for example. So there's all kinds of things you can do. And one of the things that we'll try to provide you with are some ideas of how to branch out. So we'll have extensive materials documenting different analyses that you can do, which doesn't preclude you from doing something else, but at least those are going to be offered up as examples for you. So that's kind of the basic idea.